Imagine standing in the middle of a dense forest in Pennsylvania, listening to the roar of a waterfall. Most people would build a house nearby to enjoy the view, but Frank Lloyd Wright had a different idea. He decided to place the house on top of the waterfall itself. In 1935, at the height of the Great Depression, the Kaufman family, owners of a prominent Pittsburgh department store, commissioned Wright to build a weekend retreat. What resulted was not just a home, but a revolution in structural engineering. Today, we're going to dissect the technical genius, the legendary conflicts, and the daring physics of Fallingwater. How do those massive concrete terraces defy gravity? Why did the engineers of the time think it would collapse? And how did modern technology eventually save it from a watery grave? The birth of Fallingwater is one of the greatest legends in architectural history. For 9 months, Wright did almost nothing. He visited the site, measured the rocks, and listened to the water, but he didn't draw a single line. One morning, Edgar Kaufman Sr. called Wright from a nearby town, saying he would be at the studio in 3 hours to see the progress. Legend has it that Wright sat down at his table and, in a feverish 2-hour session, drew the floor plans, sections, and elevations for the most complex residence ever designed. While this sounds like a miracle, it was actually a testament to Wright's spatial memory. He had built the house in his mind over those 9 months. Every beam, every window, and every connection to the rock was already finalized in his head. When he finally put pencil to paper, he wasn't designing, he was simply recording a finished masterpiece. To understand the engineering, we must understand the philosophy of organic architecture. Wright believed that a building should be an extension of its environment. Notice the foundation. Wright refused to level the site. Instead, he anchored the house directly into the natural sandstone ledges. The central core of the house is built from native stone quarried right there on the property. This stone spine acts as the vertical anchor for the entire structure. The most famous example of this integration is the living room fireplace. It is built directly on top of a massive boulder that the Kaufmans used to sit on before the house was even built. By making the boulder part of the floor, Wright blurred the line between the natural earth and the human-made shelter. Let's dive into the core engineering challenge, the cantilever. In structural engineering, a cantilever is a beam that is supported at only one end. Imagine a diving board. The weight of the board and the person on it creates immense tension on the top of the beam and compression on the bottom. Fallingwater uses massive reinforced concrete cantilevers to create those floating terraces. To make this work, Wright had to balance the weight of the terraces against the heavy stone core of the house. The terraces are essentially leveraged into the hillside. However, the 1930s was a transition period for concrete. Wright wanted the terraces to look thin and elegant. To achieve this, he used a specific mixture of concrete and integrated steel reinforcement. But there was a problem. The mathematics of the time were not yet sophisticated enough to calculate the long-term creep, the tendency of concrete to deform under its own weight over decades. The construction of Fallingwater was a battlefield. The engineering firm hired by the Kaufmans, Metzger Richardson, was terrified. They told Kaufman that Wright's designs were dangerously under-reinforced. They predicted that as soon as the wooden supports were removed, the house would plunge into the stream. Wright was insulted. He told Kaufman, "I have put so much more into this house than you or any other client has ever deserved." Secretly, however, the engineers added nearly double the amount of steel that Wright had specified. When Wright found out, he was livid, claiming they had ruined his design's lightness. Ironically, modern analysis shows that if the engineers hadn't added that extra steel, the house likely would have suffered a catastrophic failure within its first year. This conflict remains one of the most famous examples of the tension between an architect's vision and an engineer's reality. The engineering genius extends to the interior details. Wright hated clutter, so he designed nearly all the furniture to be built in, literally part of the walls. One of the most impressive details is the mitered glass corners. Look closely at the windows. There are no metal frames in the corners. Wright bonded glass directly to glass. This removes the visual stop at the corner of a room, making you feel as if you are standing in the open air. Even the floors were an engineering choice. They're made of hand-waxed local flagstone. Wright instructed the craftsmen to polish them until they looked like the wet rocks in the riverbed. He wanted the sensory experience of the river to follow you into every room. Building a house over a waterfall is a romantic idea, but it is a nightmare for maintenance. Fallingwater faced two major enemies, gravity and water. Because of the high humidity from the falls, the house was constantly damp. The Kaufman family jokingly nicknamed the house Rising Mildew. The flat roofs, revolutionary for the time, were prone to leaking, and the lack of proper thermal breaks in the concrete caused massive condensation issues. More seriously, the cantilevers began to sag. By the 1990s, the main terrace had sagged by over 7 inches, 18 centimeters. The creep of the concrete was becoming a structural failure. The masterpiece was literally sinking into the water it was meant to celebrate. In 1997, a monumental restoration project began. Engineers used a cutting-edge technique called post-tensioning. They carefully opened the floors and drilled through the original concrete beams. They inserted high-strength steel cables and anchored them to the stone core. These cables were then tightened with hydraulic jacks, effectively pulling the terraces back up and freezing them in place. This high-precision surgery saved the house without changing its external appearance. It was a 21st-century solution to a 20th-century dream. Fallingwater remains the world's most famous private residence because it represents a perfect, if precarious, balance. It is the moment where human engineering dared to shake hands with the raw power of nature. It teaches us that great architecture requires risk. It requires an architect brave enough to imagine the impossible and engineers clever enough to eventually make it stay. If you found this technical deep dive helpful, hit the subscribe button. In our next lesson, we'll head to Dubai to see how the Burj Khalifa uses a buttressed core to stay standing in the desert winds. Thank you for watching, and stay curious.